नमस्कार मित्रांनो, पुन्हा एकदा तुमचं स्वागत आहे मराठी AML या चॅनलवरती. सो टुडे वी आर गोइंग टू सी दी नेक्स्ट पार्ट ऑफ आवर series end-to-end machine learning is how to select the model and how to train the model. So we are going to see in detail, but before that let me revise in what we have seen as of now. So as of now we have understand how to look at the big picture of any machine learning problem, how to get the data. Once you get the data, how to gain the visualization, okay, how to visualize the data and how to gain the visualization, get the insight with the help of those visualization, and then prepare the data for your machine learning algorithm. Now we have the algorithm, we have the data with respect to machine learning algorithm. Now the main part is to train our algorithm based on our whatever data we have, so that if in case we receive any data related to our data, our model is able to give the prediction. So uh, just to revise the things, we are going to do the prediction of house price, okay, in California state. So I request you guys, if you miss my previous video lectures series, then please go and watch it before come to this lecture, because it will make your base very powerful and you can understand the things very easily. Very soon we are going to finish this series and we'll jump into the next part of next chapter of this book. Okay, so till that time please watch this video till end. So let me open my Jupyter notebook where I'm going to explain how to train. So before this we have created a pipeline. That pipeline will help you to do the one hot encoder. If you want to add new features, that is contribution, attribute addition, that function we have already developed. And there is a something how you can convert your categorical attribute into the numerical attribute. So the advantage of the pipeline is to, with a single function, you can apply all this information on a data. Now again, please watch the previous videos on this so that you will get how to achieve the same, which is a very basic and I can say universal steps in any kind of machine learning and the deep learning project. Now we have the data. Let's jump. So basically this is a regression based problem. I already explained what is the difference between regression and classification. So this is a regression based problem. So the simplest form of regression based problem or the algorithm which we are going to use is called as a linear regression. So to use the linear regression, I'm using the sklearn package to get the linear regression. So how we can get, say, from sklearn dot linear model, okay, and from there I'm going to import the linear regression class, okay, and I'm going to initialize this object. So linear regression, okay, I have initialized here, and then I'm going to fit my data. So I already have prepared my data, so I have to give. So what is the input for any kind of linear regression, if you guys know? So this input is very simple, x and y. X is my input data, y is my predicted data. So to make my model is learn, so I'm going to do the linear regression dot fit. Fit is the method to train your algorithm, and for that I'm giving my input data as a housing underscore prepare, yeah, and my y is the housing labels. Why housing prepare? This is a modified version of my data. I cannot pass my data as it is. I need to do some kind of pre-processing, and that pre-processing I have saved into the housing prepare, and my target is the housing label. Yes, the good part, it's prompt you automatically, so you can avoid this any kind of spelling mistake. Let me run this function. So this way my algorithm learns my xy data, okay, and it gives me output as a something linear regression. Now let's do some kind of prediction. Okay, so to do the prediction I will use the I'm going to use the my train data itself. So let's say some data. Okay, I'll collect the first, I'll store my first 5 rows. So I lock, and I'm doing the slicing operation /5. So 0 1 2 3 4. So first 4 rows I'm going to take from my housing I log, and then I have some labels as well. So let's say labels equal to housing label. Okay, and here I'm going to save my first 5 rows. Okay, now I have captured my x into the sum data. I have captured the my respective y into the sum labels to check how my algorithm perform the prediction. Okay, so as I mentioned, whenever you have the data for the prediction, you have to also apply the pre-processing steps which you applied on the training during the training. So to apply that pre-processing steps, let me create a new variable, let's say some data prepare. Okay, and for that I already created a pipeline. So this is the advantage of pipeline. You no need to apply all these function individually for any new kind of data set. You can only call the pipeline which you have created and make the call the method call as a transform. Okay, call the method call as a transform, and you have to send the input as a sum data, so that your input, because see in a real world your data is a raw data. Okay, in order to give the right prediction, you have to make the machine learning algorithm understandable data. So you have to apply those transformation as well, and for that we already create the pipeline of a transformation. So I am applying those transformation on my raw data. Okay, and after that I'm going to do the prediction. Okay, let me do this and then we will check the prediction. So this step is completed. So let me do the prediction now. For prediction, okay, I'm going to apply the prediction, and for prediction I'm apply linear regression dot predict. Okay, linear regression dot predict, and here I'm going to send my pre-processed data. So some data prepare to check how the what is the output we are getting. So once I execute it, I'm getting some kind of this prediction. So this is nothing but my housing price for first 5 rows, but I know I have my actual data as well. So let's see my actual housing price value to check how my algorithm is performing on my training data set. So for that I'm going to, so this is a, so to print, let me do the typecasting in the list and then some labels, and let me print out the price. So if you can see, I got the price. The first price is 85,000, which is in dollars basically, but it gives us 72,000 more. I can say not exactly, but around to 85, close, some difference of 10 to 12,000, but yeah. Second is 30,000, and my actual one is a 20, I think 2,79,000, which is a very high difference, right? Yeah, it's very high difference. Third one is 1,52,000, but it's giving 82,000. So this look like that my model is, my linear regression model is not performing well, and this is an example of, this is a example of what I can say overfitting, sorry, underfitting. So what is the meaning of underfitting? Your algorithm is not able to learn your training data set properly, and this is called as a underfitting. But this is what we can see on our by our eyes, but let's see how it will look like with the matrix. And for that we are using the Rmse, that is mean square root mean square error matrix we are going to use. So for that let me import the package sklearn dot matrix, and I'm importing mean square error. If we take the square root of the mean square, it will become the RMSE. MEC means mean square error, RMSE is root mean square error if you take the square root. So I'll take the mean square error first, and then I'll do the square root using the NP. Okay, now housing prediction. Okay, so housing prediction is equal to, so above this I have done on my sample data. Let's do the, so in order to get the RMS score, I have to do the prediction on my whole data set, right, which is which I have stored, which I have saved into the housing prepare. So let me first linear regression predict, and I have to pass the housing prepare. Okay, so this is my actual transform data I have. uh, yes, it's a predict. I think that is correct. Yeah, linear regression. Yeah, it's correct. Okay, and then after that I'm going to calculate the mean square error first. Linear regression mean square error. For that I uh, I will initialize the mean square error here, and I'm passing the actual output, that is housing labels, and with the predicted output, that is housing prediction, right? So once I have the linear regression mean square error, I have to, if I want to calculate the linear regression RMSE, I need to just take the square root of the this function. So numpy square root of linear regression mean square error. So if I take this, I'll get the RMSE score, and let's print out the RMSE first. So once we print this, okay, some error, what is that? One means, okay, I spelling mistake guys, sorry for that. Let me run. Yeah, so we are getting 68,627. So this look like it's a very huge number. So root mean square, actually we try to make this as lower as possible, close to zero. When this value is very lower, we say that our model is very well performed, or we can say it's good fit to our training data set. So whatever we have seen with the value, by just visually do the comparison, we understood that our model is not performing well with the training data, and same has been same has been confirmed by the root mean square error as well. So this says that our linear regression model is not good fit for this kind of training data set. Now if we have the underfitting data set, so generally, okay, general steps to overcome underfitting is first try complex model like decision tree or the random forest or the XGBoost. Okay, complex algorithm, or try to add, or second you can say try to add more feature, because current algorithm is not able to learn the existing features. So try to add more feature to overcome. But I think to add the more feature, it requires a lot of time to understand more deeply, and it requires some time. Okay, you have to talk to the SMEs in that area. But better, which is a very easy one, is try to complex algorithm like decision tree. So let's apply first complex algorithm, and here we are using complex algorithm called as a decision tree. So sklearn, again it decision tree contains in the tree class. So sklearn.tree import decision tree regressor. So there are again two type of decision tree we have. One is a decision tree regressor and decision tree classifier. So we are using regressor because we are solving regression based algorithm. Let me initialize this class. So decision tree, and create the object tree regressor. Okay, my is ready, and let me pass the data. So I'm not going to do the sample data testing, we directly apply our, just to save the time, let's directly apply our whole data set. So we have housing prepare. Currently we are not taking any extra customized parameter, because that will come later when we are going to see the when we are going to learn the hyperparameter tuning. But as of now we are just focusing on the as it is input. So housing prepare is my X and housing label is my, so this is my training data set guys, housing labels. So I am going to train my decision tree model on this. Okay, I think it's ready, and after that we are going to calculate the Rmse score. Okay, so again so what we can do, let me save some time. Okay, by copy pasting this, what I'm going to change, I need to change the, instead of linear regression we are using tree regression dot predict with the training data set, and then after that we calculate the, here we will get the root mean square, sorry, mean square error, and we are passing this MEC to the NP square root, so that we will get the root mean square of the decision tree. Let me change some here just to save our time guys. Okay, nothing else. So once we calculate this, let's see what Rmse is. Oh, that's great. Now here we are getting the 0, means your training data set is able to fit perfectly perfectly to the decision tree algorithm, or you can say your model. Okay, so but this may be case of overfitting, right? And to check, let's do some kind of, now you can see, okay, RMS is 0, but let's see practically whether uh, it is really giving the exact answer or not. Okay, so just to save our time, let me do some paste. So once we do the tree prediction on some data prepare and check the actual prediction, you can see actual housing price, you can see there is a no difference. Yeah. So if I do the prediction, see, it's a 7200, it's 7200, it's 22 lakh 79, it's a 2 lakh 79, $82,700, 82,700. So you can see my model works perfectly well. It able to predict my, it able to give my output as it is what actual we have. Okay, but this is this, see, yes, we have the 0, RMSE is 0, but it may learn to the overfitting. Suppose in case if I have the new data, now I'm using the training data, but there may be a chance of we are getting the, we are getting the uh, not good output with the unseen data. So the focus in any machine learning algorithm is not to get the 0 or perfectly RMSE score or MEC score. Our aim is to get the generalized model. It's okay if you are getting the low score on training data set, but try to make your whatever unseen data, it will predict at least 70 to 80% data correctly. So our focus should be develop a generalized model, not a perfectly fit model to your training data set, so that the accuracy is more close to or more than about to 70 80, or if it is 100 then it's good, but try to make that generalized model. And to have this generalized model, there is a new concept called as a cross validation, and this is the best way to evaluate model using the cross validation. So what is a cross validation? Let me first explain that, and then we will practically check how we can use the cross validation in code. Okay, so so this is what actually guys the cross validation. So what happen in cross validation, we are sending, we are dividing all. So generally if we don't use any cross validation, so generally what happened that we are dividing our data into the training and test data, and we are passing those training and test data to the model, and based on that model gives our prediction. Okay, but to overcome this issue, what we are going to do, we are divide our data into the folds. fold. Let's say if I mention my cross validation is equal to 5, so my training data is divided into the 5 fold. Okay, so what we are doing here, we are making one fold as our test data. You can see the color in blue. We are making that fold 1 as test data and passing the remaining data, that is fold 2, fold 3, fold 4 and fold 5 for the training data. Okay, similarly next time again we make the fold 2 as our test data and remaining is our training data. In split 3 we will make the fold 3 as a test data and remaining fold as a training data. So this goes iteratively till how many fold we have. Okay, and accordingly we are going to do the final evaluation on the new test data. So this way we are able to see whether our model performs well or not using the cross validation. So that, see, in our, so in now we are passing our data into the training and test. It may perform well, but what happen if there is a new test data comes? How we can evaluate our model performs well or not? Okay, so to overcome this thing, there are the two way. Either you get the new data, which is a bit difficult, but which is a, I'm not saying it's too difficult, but slightly difficult, but better if we can divide our own data set into the folds. Okay, whatever folds you can see, and make that fold as a test and remaining one training, and the process goes on iteratively so that our model can do the perfect evaluation. Okay, so to showcase how, I'll show you here how the decision tree may not good when is, as actually it is giving the 0 RMSE score, but when we are doing the RMSE cross validation, it may not perform well than the linear regression. How? Let me show you. So to use the cross validation, for that we are using sklearn dot model selection and import the cross val score. Okay, and for that I'm initializing the scores is equal to cross, sorry, cross val score, and here I'm passing first tree regression based model as my as I already have that model, and then I'm passing my input data as housing prepare, and my destination is housing labels. Yeah, and here I'm mentioning my scoring methodology will be the negative. There are many is available, you can check the sklearn documentations what are the other scoring methodology we have, but as we are using the mean square, so I'm using the negative mean square error. Now the question may arises in your mind, why negative? Because the intention of cross validation to get the uh, utility function to get the value as much as greater than lower. Okay, so that's why we are taking the negative mean square error, but when we are calculating the root mean square we are giving the minus sign. Okay, and then after that we are mentioning our cross validation parameter as 10. It means that I'm dividing my data set into the 10 folds. Once done this, I'm going to calculate my RMSE scores. To calculate Rmse score, I have to use the np square root, and as I have used the scoring as a negative mean square error, so here I'm using the giving the minus as a score sign, and then I'm going to calculate this. Okay, so I think there is again a spelling mistake, negative mean, yeah, spelling mistake, yeah, square error. So it will take some time, as I said. Okay, it's completed too fast, good. And let's to display this the result, I'm we have the let's have the one function called as a display score, where we are passing my input as a scores, and here we are, let's print the scores. Let me, just to save our time, we will print scores. So here what we are printing the score first, then we are printing the mean of the score, and then standard deviation. So we already have, and let's now display the score using the using the tree algorithm. So for that we are passing the tree RMSE score. And once, okay, now if you can see, we got the almost mean of tree, it's a 71,459, and the standard deviation is 2349. So you can say that your model is performing well with the standard deviation plus minus 2349. So 71459 plus 23459 and 71459 minus 23459, in that range, okay, plus minus in that 2349, in that range your model is performing well. Now we have the RMSE score of tree. Let's calculate the RMSE score for the uh, linear regression model using the cross validation. Okay, so I already explained how to use, so just to save the time, let's take the result directly. So display scores of, so this is a linear regression. I am passing my algorithm as a linear regression, housing prepare labels, and we are using CV10. Okay, so display scores linear RMSE. Okay, so let's print out the result. Okay, the this is wrong. Okay, let me print the result. Display scores. Yeah, so here we are getting the results is a 69. Now if you can see, the result of display score is 71,459 here, but with the linear regression we are getting the score is very less, which is a 69. So in case of cross validation, our linear regression, though linear regression model is underfitting, but it performs well in terms of linear regression. However, it uh, performs well better than the tree based algorithm. So this is about the decision tree and the linear regression. So this gives the intention that my decision tree model is fitting badly with my data, but and it also performs worse than the linear regression. So I need to try the more complex model. So this is the benefit of using the cross validation. So for that we are going to use the random forest based model. Okay, so let's try the random forest based model. So here we are initializing the random forest. Let's train our data on the random forest, and then we will calculate. So random forest, we will see in detail in upcoming lecture how random forest is, but as a just in one line, random forest is again a combination of your decision tree, and it's a bagging kind of technology. Okay, so I will explain in upcoming lecture how random forest work, but it is a complex and it's a bagging kind of technique. And here we are passing our data to check the prediction. Now if you see the forest RMSE, okay, random forest RMSE is a 18,775, which is a really good than decision tree, because if you see our decision tree RMSE, which is coming as a something zero, is actually, but here it is not actually fitting, though it's not performing well than the decision tree, but it's good. As I already told you, we have to make the model as a generalized model. Now let's see our validation, cross validation RMSE score, which will actually tell us whether your model is generalized or not. So let's calculate the RMSE score based on cross validation, and then we will display the score. Okay, so it will take time here. As I said, it's a complex model and it's dividing our data set into the 10 fold, okay, and 10 iteration, right? And once it does, we will see how the random forest it look like. So as of now, till this is going on, we just to revise in a time. So we have seen three type of regression model. One is a linear regression model, second is the decision tree model, and third is the random forest. We are going from very basic to the complex model. Linear regression is very basic model which will help you to understand where how your data is linear regression is good for not. With that result you can see it is a underfitting or overfitting. And also we have seen the cross validation technique. So using that cross validation technique, it really help you to evaluate your model perfectly without having the new data. Now it still goes on, but yeah, so let's give some time. Okay, yeah. So meanwhile we were going to see the display score. So we have calculated the Rmse score of random forest using the cross validation. Now let's display uh, the score of random forest. So we are getting some. Okay, so we have did a spelling mistake of display score here. Okay, so let's use display. Let me correct this. Okay, it's okay. Yeah, and let me run this. Okay, so we have got the display score is $50,306, which is I think good. If you can see the score of uh, tree based algorithm, which come around a 71, so almost 20,000 reduction in that. So it state that the complex model works well, that is a random forest, with our data, and it overcomes the two solution. So with the linear regression we understood that linear regression we got the underfitting issue. Okay, and for the decision tree algorithm we have faced the overfitting issue. But with the random forest, this two issue, that is underfitting and the overfitting, has been solved very good. But there is a one more problem, that still I cannot say the random forest is perfectly I can say perfectly fine. Okay, if you can see the RMSE score of random forest without cross validation, it comes at around the 18775. So to overcome this, which is again a much lower, so to make the generalized model we may need to do some kind of regularization. Okay, to apply we need to apply some regularizations. Okay, and that comes when we are doing the hyperparameter tuning. So I hope you understand how we can select the model, and once how we can select the model, how we can train the model, and how we can select which model is best for our data using cross validation. In upcoming lecture we will try to see how to fine tune the model, which is basically nothing but the hyperparameter tuning. Okay, I hope you like my explanation. So just please don't forget to like, share, and subscribe my video. Till that time, all the best.